This is one of the dimensional analysis problems. And I'm going to just do some guided reading. Harold works at a state park. He needs to seal the redwood deck at the information center to protect the wood. He measured his deck. He finds that it is a kite with diagonals. So just kind of looking over here, I'm seeing the kite right here. And it has diagonals that are shown. And the diagonals are 40 and 70 feet. So basically I'm looking at this picture and I'm going to just pull it out, kind of like refresh your memory. Diagonals are perpendicular. Okay, so each gallon of sealant covers 400 square feet. So that's a unit kind of rate thing. So we know 1 gallon covers 400 square feet. You could also think about it in the reverse order, that if you have 400 square feet, you can cover a gallon. I mean, you need a gallon to cover that area. So that's what that tells us. And you have to apply this sealant every 6 months. So that's important information. So the question is, how many gallon containers should he buy to protect the deck for the next 3 years? So we know that if we think about one application, I guess you could think of it this way. Will last for 6 months. And we need to know how many gallons per year, because then we could just triple the answer. So that's kind of the way I'm looking at the problem. So it's an area problem. And so I think over here I would just kind of remind myself about kite area. And when you think about kite area, there's formulas, and the formulas come from the area of a triangle. So a kite has 2 congruent triangles. And if you look at that picture, this blue triangle, you can think of it as having a height of 20 and a base of 70. So the area of the blue triangle is 20 times 70, but since it's a triangle, I would divide by 2, but since there's 2 triangles, I would multiply by 2, and so the area of the kite is really 1,400 square feet. So that's kind of thinking it through without a formula, but you know, there's always a formula for these shapes, and so some people like the formula, so you multiply the diagonals and you divide in half, and you're going to get the same thing. So that would be 40 times 70 divided by 2, and that's the exact same thing. It just sort of looks different. 2 goes into 40 20 times, so we still get 1,400 feet squared. And That's the surface area. So if I were gonna put that into dimensional analysis, I would say that that would be the area per one deck. So, in other words, one deck is congruent to 1,400 square feet, or you can think of it as 1,400 square feet is the area of one deck. So before I actually solve the problem, I just wrote out all the different possible ways to look at units. That doesn't necessarily mean that I'm going to use everything. I'm just sort of putting in my scratch work. And then I just need to think about how I can show my work with that information. And, you know, one idea is just sort of to kind of think through really what the question is. And the question was, how many gallons should I buy to protect the deck for 3 years? So I think it's probably safest to just not worry about the 3 years yet and look at the question. It's asking how many gallons that I need to protect the deck. So basically, I want to figure out the gallons per deck. And then I'm going to figure out the second part. And the second part is that if I know I need one application, for one application it would only last 6 months. This you would probably do, you know, I'm guessing with mental math, but you know there's 12 months in a year, so we need to do 2 applications a year because the 6 goes into 12 twice, right? So we would just do 2 applications per year. Make that a little thinner. And if we had 2 applications per 1 year, then we need to multiply that by 3 years. So basically, I think it would be safe to say, with or without dimensional analysis, you could see that you need 6 applications. So let's just focus on the dimensional analysis and why I took time to write all those different things out. If I want to end up with gallons per deck, I think what I'm trying to show you is I need gallons in the numerator. And so when I look at my choices over here, I would prefer to start with gallons per 400 feet rather than 400 feet per gallon, because I need to have gallons in the numerator. So I'm choosing this one, and I'm not choosing this one. I'm just not going to use that one. So this gives me gallons per 400 feet squared. But I also know that my deck is 1,400 feet. So I'm going to bring that over here. And now I look at my units. In my units, the squared feet cancel out. So now I have gallons per deck. So I just have 1,400 divided by 400, and my units would be gallons per deck. And then I could simplify both of those by 100. That's the same as 14 over 4, which is equal to 7 over 2, or 3.5 gallons per deck. So if you have to buy whole gallons, you would have to round up to 4. Sometimes the problem is very specific and sometimes it's not. But since deck paint can be saved, I would not round up to 4. I would say that I know I need 3.5 gallons per deck, and I need to multiply that by 6 applications. And when I do that, I'm gonna have how many gallons per deck I need, and then that's gonna be 6 times 6 for the number of applications, which is what we figured out up here. So 6 times 3 is 18, and half of 6 is 3. So I need 21 gallons for my deck. So 21 gallons of sealant's needed, and that would take care of the whole deck for the 3 years. So I was just gonna take a look at this problem, make it a little smaller. This one's already, I talked about a little bit in class with a couple of students, but if you look at the picture that you see up here, they point out that there's 3 flower beds, and each flower bed's trapezoid. So you might notice there's sort of a dotted line showing you the trapezoid shape. So it's really similar to the last problem, because before you start the problem, I think you really want to make sure that you have the right area for your figure. And so we just over here found the area of one of the trapezoids, and that's what this picture was about, because the height of a trapezoid in this problem was 7, and you see that right there, but you could also think of it inside the trapezoid. And so basically I found out one trapezoid was 112 square feet. So when I read the problem, landscape architects designing 3 trapezoidal flower beds to wrap around the 3 sides of a hexagonal flagstone patio. The question's what's the area of the entire flower bed? So over here you'll see that I tripled, because the entire flower bed would be, each trapezoid is 112 square feet, and there's 3 of them. So really I have 336. When you multiply this out, you get 336 square feet per flower bed. So that was the first part, and then the landscape architect's fee is $100. So this $100 is before any of the work is done, plus $5 per square foot, and so that's the variable rate. So what we did here was we figured out if it's 336 square feet per flower bed and $5 per square foot of work, feet square cancels out. That's why those were canceled. And I just have dollars per flower bed. So if I multiply 336 times 5, that's going to be the cost of the dollars per flower bed. Then I have to finish the problem by taking $336 and multiplying it by 5, and then adding $100. And that's going to give me the total cost. So this is the cost for the flower beds, and this is just the flat rate for the company. Then you multiply those out, add them together, and that should give you the correct answer for that problem.